Alright, welcome back guys. Alright, this video, we got a little electrical video here. I was over on Matt's channel. This is, if you're not familiar with him, his username is Schrodinger's Box. And I was looking over his IAT video that he did, and great job, Matt. And I'd seen the video a while back, and I just went over there just kind of see comments, you know, see what was going on. And it looks like there was a lot of confusion about how a IAT circuit works. That's an incoming air temperature sensor. And by the way, if you're not familiar with Matt's channel, I'll put a link down in the bottom in the description of this video. And he does a great job in going over the diagnostics of how to get right down to the part. In other words, he's teaching you not to be a parts changer, which is what I believe too. I believe you should know the circuit operation, and that makes you a better diagnostician. So what we're going to do here is we're going to break down this here circuit so that we can understand how it works, because it looks like you know, there was a lot of confusion. Looks like different people over there on Matt's channel had all these different ideas about how a circuit works, and it's a really simple circuit. In fact, it's probably one of the simplest circuits on the car, you know, for you to work on. So let's get started and let's break this circuit down, and you'll probably know more about IAT circuits than you ever want to know. But knowing the most that you can is going to help you in your diagnosis. And by the way, this is also going to help you on ECT circuits. That's the engine coolant temperature sensors. These are two-wire devices, just like the IAT. Once you got this, then any two-wire temp sensor circuits is all going to be the same. They're going to work exactly the same way. Alright, so let's get started and let's get on it. Alright, first we're going to have the PCM. Alright, I'm going to draw the PCM up here. Alright, now inside of the PCM we have a voltage regulator. Alright, I'm going to draw that up as a little block. Now this probably might be a 7805, and this is a 3-terminal device, voltage regulator. This right here is going to be our input. Okay. Now input is where our source voltage is coming from. This could be anything, say from, let's say 12.6 volts when the car is off, and let's say it can go up to 14.2 volts. Of course, that's DC. Now this is going to go all the way back, of course, you know, through the ignition switch, through fuses, until eventually we're going to get back to the positive post on the battery. Alright, now we're also going to have an output. Now this output coming out of here is plus 5 volts DC. Now that right there is known as a reference voltage. Now this voltage does not vary. Although this input voltage over here on the regulator on the input side is varying, this voltage on the output of the regulator is not going to vary. It's going to stay 5 volts DC. So it's a stable voltage. Now we're going to need a ground connection. Now this is going to go back, of course, out to the minus on the post on the battery. So there's our DC negative, okay? Now, and if you want to, we can just throw a ground on there. Doesn't matter. Alright. Now, this 5 volts is going to come out, and it's going to go to a fixed resistor that's inside of the PCM. And we're going to come on out. We're going to come on out. And right now, I'm not going to draw a connector for the IAT, so let's just draw it. There's our resistor. Going to put an arrow, shows that the resistance will vary. The other side will go back into the PCM, and it's going to go back to ground. Okay, so here's our IAT sensor. Now this right here is where we are going to look at our voltage. This is what the PCM is going to be looking at. That voltage is going to go to an A to D converter, or analog to digital converter. Okay. Now, a computer a digital computer cannot measure an analog voltage, is what we're looking at, directly. Digital computer works on ones and zeros, which is basically ones will be a higher voltage, say 5 volts positive, and a zero, which will be 0 volts. Now this being here as electronics, of course it'll have some supply volts to power up the integrated circuit. So more than likely, I would say probably that 5 volts is not only feeding outside just to external circuits, but it's also feeding internal circuits in the PCM. So that means that this electronics here has got to be powered up. And for our purposes, let's just say it's powered up off of the 5 volt DC reference voltage. All right. So far so good, right? Now, if you look right here at the IAT sensor, the IAT sensor is a resistance that will vary with temperature. All right. Now, let's talk about thermal resistances. Most resistances, they'll vary their temperature. When you vary the temperature, the resistance will change. But a lot of them, most of them, you think of as you heat a resistance up, it just thinks, well, the resistance should go up. And that's true. Electric heaters, when they heat up, the resistance will actually increase. Another example is in industrial applications where they're, say, measuring bath temperatures. They use a device called RTDs. That's a resistive thermal device, or you might see it as a resistive temperature device. In those cases, as the temperature heats up, the resistance is going to go up. Now, the resistance when it goes up, as with the temperature goes up, they're known as with a positive temperature coefficient, PTC. All right, but on cars, such as engine coolant temp sensors, IAT sensors, incoming air temperature sensors, the resistance is actually backwards. As the temperature goes up, okay, then the resistance will go down. All right, so it's totally backwards from a lot of the resistances that's out there as far as them going up with resistance and temperature. Those that I'm just talking about as far as on a car, those are called negative temperature coefficients. You'll see that as an NTC. I bring that up so if you see an NTC, that's all they're talking about. It's just working backwards the way you would normally think. Okay? So now let's get back to our circuit here. Now for the purposes of what we're going to show here, let's say that this here temp sensor, okay, can vary from 1,000 ohms all the way up to, let's say 91,000. Okay, so that's 1K to 91K. Now from what we just said, we said that the 1K, the temperature is going to be hot, right? So the low resistance, we're going to say 1K is hot temp, all right? And if we get to 91,000, then we're going to say that is a cold temp. Okay? See how it's backwards than what we would normally think of? So like I said, this is an NTC type sensor. Negative temperature coefficient. All right. Now when we look at this circuit, we got two resistors. These two resistors are in series across a 5 volt source. 5 volts positive being up on the top of this fixed resistor, and this one down here is going to ground. Okay? So, in effect, what we have, and we draw it to even make it simpler, there's our fixed resistance. It's carbon resistor, metal film resistor. Resistance is not going to be varying. Now, it'll vary, you know, with the heat, but not very much. And then down here, we have our IAT. There's our 5 volt reference. Here's our ground. And right there is what we're going to be looking at, which is the voltage out, which is going to the A to D converter. Okay? So in effect, when you put your voltmeter right across the IAT sensor, one here, and you can get access to that right out there at the temperature sensor. You are measuring what the computer is seeing. In fact, if you look at your scan tool and if you got a voltage reading on it for your IAT or say ECT sensor, you're going to be measuring that same voltage that you measure with a voltmeter. All right? Let's run through this a little bit. Let's do a little Ohm's law. Now you can see how the voltage is going to change with the resistance changes. All right? Let's call this one right here R1, and we're going to call this one R2. Now, for the purposes of what we're going to be doing here, okay, let's call the fixed resistor here, let's make him 9K. Now, I picked out some values here that will kind of work out even, so it'll make it even easier to understand. All right, so we have our 9K here, and we have our, we'll start off with a 1K. We're going to look at the temperature of the air is pretty hot. Or if you're looking at the ECT, then the temperature of the coolant is pretty hot. All right? Let's do a little bit of Ohm's law first. And here's our circuit that we're going to be looking at. Remember, we're going to be looking at this right here. Okay? Now, we have E equals IR. Ohm's law. E is electromotive force. That's the units is voltage. I is current. I stands for intensity. R is resistance, which is measured in ohms, and the current over here is measured in amperes. All right, let's transpose the equation a little bit. I is equal to voltage divided by R. Last one we got is resistance, which is equal to voltage divided by current. Okay, let's say the first thing we want to know, if we want to figure this thing out with a little bit of Ohm's law, let's say that we want to look at, first we need to know the total resistance of this circuit. This is a series circuit. It is nothing no more than a voltage divider. A voltage divider is going to divide the voltage that is fed, which in this case is 5 volts, and it's going to divide some voltage across the IAT sensor, and it's going to divide the rest across the 9K resistor. Okay? Now, the total resistance of this circuit for a series circuit is 9K plus 1K. So, RT, resistance total, is equal to 10K. 10K ohms. Okay? Now, what we want to know now is what is the current through this through this circuit? Well, what we have to do is we'll take, and we're going to use this one right here. We want the current. What's our voltage? Our voltage is 5 volts. So I equals E divided by R. So now I equals, voltage is 5. What is our resistance? Our resistance is our total resistance, which is 10,000. Okay. Now, if we get a calculator, we figure that out, and it looks like we're going to get 5 divided by 10,000, and we're going to get 0.0005 amps. Now, that is the current that is flowing down through this circuit, okay, from 5 volts all the way to ground. Now, if I put my amp meter right in there, I'm going to get that current. If I put my amp meter right there, same current. If I take my amp meter, put right here, same current. So the current in a series circuit is the same no matter where you measure it. Okay? Alright, so we have the total current coming down through the circuit. Alright? Now that we have the current that's coming through this resistor, now we can figure the voltage drop that's across, say, this 1K sensor. Now, if we take and go back up to this equation, which is E equals I times R, we want to find voltage. Well, what's our current? Our current is 0.0005 times R. Well, what's our resistance? Our resistance is 1K, so that's 1,000. Now, if I move my decimal place over 3 places, because I have 3 zeros, then I'm going to get 0.5 volts is equal to voltage. So voltage is equal to 0.5 volts across this here resistance, okay? So that is what the A to D converter is seeing. It sees the 0.5 volts and it knows that the engine's hot. And it can use an algorithm inside the PCM based on the voltage, and this here sensor is linear as far as resistance and versus temperature, so it's linear, it's just a straight line. Alright, now let's go back up here. Let's look at the 9K. Well, the 9K is going to be little Josie's having being a good watchdog. All right, so we have E equals our current, remember, is 0.0005, and our resistance is 9,000. Okay, now we have that this 45, which is going to be 4.5 volts. All right, now that is the voltage that is dropped across this resistor here, the 9K that's inside the PCM. But this voltage is not looked at by the PCM. Remember, everything is in reference to ground. So if I had my voltmeter and I put my negative lead here and I put my positive lead here, I'm going to measure 0.5 volts. Now if I take my voltmeter, and let's say I could go inside the PCM and I move it just like this, right directly across that, I'm going to measure 4.5 volts. Now one thing here, if you want to look at, is we have 0.5 volts here, we have 4.5 volts up here. If I take these two voltages and add them together, you notice what I get? Add them together, and I get 5 volt DC. And that's a law called Kirchhoff's law, that voltages in a series circuit, when added together, must always equal to the source voltage. Okay? Now, so what do we just learn right now? We see that with a low resistance, we get a low voltage. Now, let's flip things around. Okay? This time, there's our 5 volts. We're still going to have 9K inside the PCM. There's our IAT. But now the engine is cold, and now we're going to come back and we're going to look at a value of 91,000. So now this thing is going to 91K. Okay. All right. What's our total resistance? Total resistance is going to be 91,000 plus 9,000 is going to give us 100,000 ohms. All right. What is our current coming down through here? Well, if we go back to here, we say voltage divided by resistance. Our voltage is still 5 volts. So let me put the equation down here so you guys can see it. And we're going to say 5 divided by our total resistance, which we said was 100,000, right? Now, if I take 5 divided by 100,000, okay, then I have 1, 2, 3, 4. 4 zeros. So now we got 0.0234 amps. Okay? That is the amount of current that's coming down through this circuit now. Now let's look at what our voltage is going to be. Remember, this is our V out, going out to the A to D converter inside the PCM. Now if I take this here and I want to know what the voltage is across that sensor, then I'm going to say my current is 0.00005 times 91K. And if I multiply that out times, oops, let me put a 1 in there so you guys can see that that's 91,000. And I say times 91,000, then I'm going to get 4.55 volts. Okay? So now at this point, I'm going to have 4.55 volts across the IAT sensor, which is what the computer is going to see. So now, what do we learn? We learned that as the resistance drops, the voltage is going to drop. We learned as the resistance increases, the voltage will increase. Okay? Now, we could figure out what this voltage is up here, but from what I've already told you, we already know what the voltage is across this. All we have to do is take 5, subtract 4.55, and now we know what the voltage is across this here resistor that's inside the PCM. So if I take 5, subtract 4.55, then I will have 0.45 volts up here. So that's for that one, and this one is for down there, okay? All right, does that make sense? Hopefully that makes a little bit of sense. Now I'm going to show you another way how to do this, and it's going to make it even simpler. All right, let's go over to the other side since I'm running out of paper. There's my 5 volts. There's my V out, right? Remember, this is inside the PCM right here. Okay, and here's my Iat sensor. Remember, this is going back into the computer, which is ground, and I've been just putting it out here just to make things a little simpler. All right, so I'm going to call this one right here R1, and I'm going to call this resistance up here R2. Now I want to know what is the voltage that's across this, and we're going to use the same values that we did before. So this is 1,000 ohms right here, right? This one up here is 9,000 ohms. All right. Look at the resistance that you want to know the voltage drop across. Well, in this case, we want to know this one here. So I'm going to put down R1. And I'm going to divide that by the total resistance, which is R1 plus R2. And I'm going to multiply that times my voltage source. And that's going to be equal to my volts out, which is right here, which of course is right across the Iat sensor, which is what the PCM is going to see. So R1 is 1,000 ohms divided by 9,000 plus 1,000 equals 10,000. Cross out my zeros times my voltage source is 5. So then I have 1/10 times 5. 5 divided by 10 equals 0.5 volts. And is that not the same thing that I got earlier? It's the same exact thing. So this right here, this is called the voltage divider rule. I like to use this because it's a whole lot faster than using Ohm's law, because it's kind of several steps that you got to go through. All right, so some of the stuff in the comments, this is some of the stuff seemed like what people was thinking. All right, we have a 5 volts, right? And it's coming down. It seemed like, okay, it just came on out, and it just fed the Iat sensor, okay? And then it went back in there, and then it goes to ground, okay? And then up here, it looks like, okay, now we're going to voltage sensing circuit, all right? Of course, you all know now that that's the A to D converter. Now, here's the thing. We just said that this was a stable voltage. This voltage does not change. If it did change, it wouldn't be a reference voltage anymore. So that's the first thing you want to keep in mind. Reference voltage means a stable voltage. So, but you'll think, okay, but this resistance out here is changing, and that should change the voltage up here. No, it does not. It doesn't matter what this Iat sensor is doing as far as the resistance changing. It can change up, down, anywhere it wants. If you measure from here to here, you're going to get 5 volts. It ain't going to matter. So you've got to have a series resistor in here to create a voltage divider to split this voltage out, like we showed earlier. So that's the first thing. Another one was, well, another comment seemed like, well, as the current is coming through, that over here we had a low reference signal wire, right? And then, no, this is 0 volts. That's ground. That doesn't change. That voltage stays the same all the time, okay? So keep those things in mind, that this circuit, like it is, will not work. It will always stay 5 volts, even when the resistance side here changes, okay? All right, now, let's go over some other stuff here. let's look at some troubleshooting stuff. All right, let's draw up a little circuit. Now that you understand how the circuit works, okay, and I'm just going to put my 5 volts DC positive. I'm not going to draw the regulator. And here comes my fixed resistor. We'll just say he's 9K. Now, of course, that could vary on the car. I'm just using this as an example. Right there, that's where we're going to be looking at our voltage. This is our A to D converter, okay? And then out we go, right? Now, what I usually do, you're going to be coming out here. You're going to go to a connector. This is a female jack. Then you're going to have your male jack. Then it's going to come out to an Iat sensor, right? Then you're going to have your male terminal on him, female jack, come around, go back, and back into the PCM. All right, Iat sensor. Remember, this could be an ECT sensor too. Doesn't matter. Works the same exact way. You got one, you got them all. Okay, now let's think about this. Let's say we're in a troubleshooting thing. Something is not right. I come out here and let's say that this here wire is shorted to ground. Somewhere in the harness, touching the frame, right? Okay. I put my voltmeter across there. I put one lead here on my Iat sensor. I come across over here and I check. What am I going to check? What voltage? I'm going to be measuring 0 volts because this is going to ground. This is ground. This is, so here to here, nothing. It's going to be 0 volts. Now, if you notice that on the Iat sensor, if you have 0 volts or if you have 5 volts, you might get something on your scanner might say Iat sensor low circuit, Iat sensor high circuit, right? Well, these two values are no-nos. When the computer sees these two values, it knows there's a problem. So if it sees 0 volts, then you're going to get a low circuit. So therefore, you got something going on right here. Maybe this line right here is shorted, okay? Now, if that's shorted, is that going to hurt anything up in here? No, because see, you have a 9K resistor up here. That's still your load. You basically now, you have 5 volts across a 9K. It's not going to hurt a thing. The computer is going to see that 0 volts. See, it's all tied together. 0 volts, okay? Now, let's say that you have another scenario. You come down, and we got our connector, and let's say we don't put it in now. And I'm coming back up. There's my plus 5 volt DC. There's my ground. And all this is inside the PCM, right? And of course, there's our volts out, okay? There's our 9K resistor. Okay, I come out, and it says high circuit. Okay, what the hell? What's going on? So you put your voltmeter across there, and you put it up here. Imagine now that your Iat sensor is in there, and it's hooked up. You just put your voltmeter right across it, and now what are you going to measure? You're going to measure 5 volts. 5 volts. And you're thinking, well, look, you got a 9K, it's going to drop resistance. No, it's not going to drop anything because there is no current flow. Here's another rule to remember. Voltage drop is when you have current. If you have no current, there is no voltage drop. So if I measure here, and let's say I went way up here, I'm going to measure 5 volts. Now, I come down to here. I'm going to measure 5 volts. Now, let's say I take my voltmeter, and let's just say I can get right across that resistor. What am I going to measure? I'm going to measure 0 volts. I got 5 volts here, 5 volts here, and a voltmeter measures the potential or voltage difference between the two leads. There is no rule to say that the black lead has to go to the ground, which is 0 volts in reference to itself. So if I put my voltmeter here and I measure 5, say my black lead is there, and I put my red lead up here, the voltmeter, all it's going to do is subtract between the two voltages that it's sensing on the voltmeter leads. So there's 5 here, 5 here. I subtract, voltmeter reads 0. Okay, all right, let's look at it again. All right, I want to know the voltage. Voltage equals current times resistance. What is my current through here? Well, it's an open circuit. That means it's 0. What's my resistance? It is 9,000 ohms. 0 times 9,000 equals 0 volts. There are 0 volts across there. Okay, remember you can't have voltage drop until you have current flow. Okay, so that's kind of a scenario. And one thing you could do when you're doing looking at an IAT circuit, if you look at a scanner, that makes it real nice, because if you can see the voltage value, look at the engine cold, then you know that you should have maybe say 4.5 volts, okay? And then as the engine warms up, you're monitoring the voltage, resistance is coming down, so what does that mean? Your voltage is going to come down, right? Lower resistance, lower voltage drop. Higher resistance, higher voltage drop. Okay? So that's about all I can think of, guys, as far as going over the IAT circuit. And if you got this, you got ECT circuits, you got all the 2-wire circuits. They work exactly the same way. So this is about one of the simplest circuits that I believe is out there on the car. So you master this, understand voltage dividers. If you don't quite understand it, then ask some questions. You can ask me questions. There's a lot of stuff out there on the internet. And you know, if you get this and understand this, then you know you're pretty well on your way to doing some great diagnostics. So anyway, you guys take care, and I'll see you guys in the next video.